This is problem number 6 on the sample test problems for test number 2. Let the functions f and g be defined by f of x equals 1 over x plus 3 and g of x equals x squared minus 4. Part A, evaluate f of negative 2 and g of negative 2. So here we'll start by plugging negative 2 in for the x value in the f function. So this guy right here becomes negative 2. So we get 1 over negative 2 plus 3. 1 over 1, which is 1. And to find g of negative 2, now this x is the one that becomes negative 2. So we get negative 2 squared minus 4. And here's a moment where it's possible to make a mistake. Technically, if I do negative 2 squared as I've written it, we know order of operations that that power should come before the negative sign. So 2 squared is 4, and there's a negative sign waiting in the front. Real easy to write negative 8 as the answer. Turns out it's wrong. What we need to do is recognize that this x being squared is one thing being squared. The entire value of x is being squared, including that negative sign. And negative 2 squared is 4. And 4 minus 4 is then 0. Part B, what is the domain of f? Remember, domain is concerned with x values. What are the allowable x values to put in for this x right here? And one thing to worry about in terms of domain is taking square roots of negative numbers. We don't have any square roots here. Another thing to worry about is dividing by the wrong number. And the wrong number is 0. We're not allowed to divide by 0. So we'll just kind of put that as an overall warning. Don't divide by 0. So what we want to do is make sure that x plus 3 is not equal to 0. So this equation, or not equation, isn't very hard to solve, but generally solving things not equal to 0 is tougher than solving things equal to 0. So let's go ahead and solve this equation equals 0, and then we'll know we're going to toss out the answer that we get. So in this case, x is negative 3, and if you try plugging x equals negative 3 in, you'll get 1 on top and 0 on the bottom, which is a bad thing, which means that the domain is everything except for negative 3. So a couple of ways to write it. In set builder notation, it's a set of all x such that x is not equal to negative 3. Or in interval notation, you can go from minus infinity all the way until you get to negative 3. Don't include negative 3. Union, then we'll pick up again, right at negative 3, but don't include it again. And then go out to infinity. And so that's how we can exclude negative 3. Part C, what is the domain of G? So now what we're after is the allowable x's that can go in here. And I see no square roots to worry about, and I see no division to worry about, and there's not a whole lot left to worry about. And if there's nothing to worry about, then the domain must be all real numbers. So a few different ways to write this. You can just write that phrase, all real numbers. I can write it in interval notation, going from minus infinity to infinity. And remember, the infinities always have parentheses, never brackets. Or if you want to be really compact, mathematicians have a fancy symbol R, which stands for the set of all real numbers. One thing that's going on here is that G is a polynomial, and the domain of every polynomial is all real numbers.